mathematicians, and welcome back to day 2 of exponential functions. So, before we start off, you're going to need 3 things. You're going to need this geometric sequence worksheet in front of you. You're going to need your green sheet, and you're going to need something to write with. So, to recap, a sequence is a list of numbers. Any kind of numbers? Nope. It's a list of numbers in a particular order. And that's just a fancy way of saying that there's probably a pattern up in there. So last you learned arithmetic sequences, which is numbers with that were in a list that were going up by adding or subtracting. So let's look at this one. First thing I want you to do actually is I have a little typo up in here. If this says 16 right here, I want you to erase it so that it is the 6th term. We're looking for a smaller number. So find the 6th term. All right, so let's start off. From 10 to 40, it is about plus 30. But from 40 to 160, that is plus 120. Oh no, these are not the same. So that means that this is not a geometric sequence. I'm sorry, this is not an arithmetic sequence. So let's take it back to your green sheet. Arithmetic sequences only work for addition or subtraction. Geometric sequence work for multiplication or, can you take a guess? Yep, good job, division. So let's check over here. What if we try doing it by multiplying? So 10 to 40 is times 4, and 40 to 160 is indeed times 4. So this is going to be a geometric sequence, okay? So you should know by now that we have a formula for everything. So this is our formula for geometric sequences. Let's go ahead and break this down. The n is the same. The n right here and right here is the term we are looking for. The a1 is the very first term. Now, what we have different now is instead of a d, we have this r, which is called the ratio. So this is how much it is multiplying or dividing by. So go ahead and fill this out. So let's again copy down your equation over here. So this is a n. So it's the nth term. It's going to be a1 times r. And this is going to be n minus 1. So we have to look for our n, our a1, and our r. N is the term we're looking for. We're looking for the 6th term. Remember, we have a boo-boo back here. So this is going to be 6. A1 is our very first term, which is 10. And our r is how much it is jumping by. So it's jumping by 4. So let's go ahead and fill out our new equation. A to the 6th term equals 10 times 4 n, which is 6, minus 1. So this is our equation that we're using. So a to the 6 equals 10 times 4, 6 minus 1. All right, let's remember our order of operations. PEMDAS. First one is parentheses, but I do not have any. The second one is an exponent. Now I have an exponent right here, but we can see our exponent is an equation itself. So let's clean this up. So it's equal to 10 times 4. 6 minus 1 is 5. Now I don't know what 4 to the 5th power is, but I do know how to input it into a calculator. So we come over here to calculator. We have 4 to the 5th power, 1,024 times 1,024. Our last step is to multiply 10 times 1,024, and this is going to give you 10,240. So if we kept going with our list, it would be 10,240. All right, let's do case 2. Find the 13th term of the following sequence. Ooh. So immediately we can tell that this is going down, okay? So when we have addition and multiplication, only division is what makes it go down. So I can see that from 81 to 27, they are going down by, I can check actually, 81 divided by 27. It is going down by 3. This is going down by 3. 27 and 9 is going to be going down by 3. And so forth. So the equation we are using, because this is a geometric sequence, is, again, the one we all love. A n equals a1 times r n minus 1. So let's find all these terms. N is the one we're looking for. We're looking for 23. A1 is our very first term, which is 81. And R. Now, with R, you might want to put 3, but this is wrong because that means we're multiplying by 3. We are dividing by 3. So to make it look like we are dividing, we're going to use a fraction. We are dividing by 3. When you divide by 3, you're also taking a third of a number. So, keynote. Fraction when it is dividing. So let's go ahead and pop it in. My 23rd term is going to equal my first term, 81, times my 1/3 ratio, 23 minus 1. So let's go ahead and clean this up. Again, I have to clean up this exponent because it's very messy. So it's going to be 81 times 1/3, and I'm going to use parentheses actually because it's a fraction, and 23 minus 1 is 22. Now I'm going to take the actual exponent with its base. I'm going to bring 81 down, and over here on my calculator, I'm going to put my parenthesis. I'm going to put 1 divided by 3, and I'm going to hit my exponent button, and I'm going to put 22. So that is a very, very small number, okay? Remember, we have to multiply it by 81. So I'm going to do times 81, and I get this. So our answer is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to get 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is going to be a fraction. It's going to be a very, very, very tiny fraction, but it is my answer. And it makes sense because look, we have 81, 27, 9. It's just going to keep getting smaller and smaller and smaller. So go ahead and try these out. But before you take off, let's talk about the cases. In my first case, I was multiplying by 4. So it was multiplying by 4. But in my second case, I was dividing. I remember that when we divide, we're going to get a fraction and sometimes some decimals. But go ahead and jump out to math, and I'll see you for the next